in this video I explain about the mechanical properties of materials. Okay, so first one is elasticity. Then so elasticity is the one of the property of material. So what is the meaning of elasticity? So elasticity means, okay, so it is the property of material. It is the property of material, okay. So regain the original shape, after removing the loads, removing the loads. Okay, so this is the definition of elasticity. Then next point, the steel is perfectly elastic within the elastic limit. Okay, the steel is perfectly, okay, elastic within elastic limit, okay. So this is the very important point for competitive examinations. Okay, so during the elastic deformation, the atoms of metal are displaced, okay, displaced from their original position, but not to the extent that so they take up new positions. Therefore, when the external forces are removed, the atoms of metal return to their original position. Okay, so the atoms are displaced and so they regain the original position. Okay, then so the stress strain curve is linear in elastic range. Okay, so third point is very important. The stress strain so curve is linear in elastic range. Already you know the stress and strain curve. Okay, so this is the very important property of elasticity. Then second one is plasticity. So what is the second one? Plasticity. The second one is plasticity. Okay, so what is the meaning of plasticity? So plasticity is the one of the property of mechanical. Okay, so in this property does not regain the original shape or position, okay, when after removing the loads. Okay, so this is the definition of plasticity. Means so it is a property of material does not regain the original shape, okay, or position when after removing the loads. Okay, so for plasticity stress and strain, okay, curve, stress and strain curve is non-linear. Okay, so in case of elasticity the stress strain curve is linear. So in case of plasticity, okay, the stress and strain curve is non-linear. Okay, so because of in elastic property the regain the original shape, but in plasticity property so does not regain the original shape. Okay, so that is the property of elasticity, plasticity and elasticity. So these are two are very important. Then third one is stiffness. Okay, so what is the third one property? Stiffness. Okay, so stiffness means what is the meaning of stiffness? Okay, the ability of material. Third one is stiffness. That means third property is stiffness. Third property is stiffness. Okay, the ability of material to resist deformation under stress. Okay, so this is the definition of stiffness. Means the ability of material to resist deformation under the stress. Okay, so what is the definition of stiffness? Okay, so this is the definition of stiffness. Next, what are the units for stiffness? So generally, so we are using Newton for meter, or so kilonewton for meter. Okay, so what is the mathematical formula of stiffness? Okay, so we know that load per deflection. Okay, so that is the mathematical formula. So that means W by delta. So W means load, then so delta means a deflection. Okay, so this is the definition of stiffness. Okay, then so third point is the carbon steel is stiffer than alloy. Okay, so next point is the carbon steel is stiffer than aluminum alloy. Okay, so this one also very important point for competitive examinations. Okay, the stiffness property is more important. So consideration in design of transmission shaft. Okay, so this is the very important. Okay, so in design of transmitting shaft. Okay, so this is the information about the stiffness. The next property is toughness. Okay, so what is the meaning of toughness? Means the ability of material to absorb energy before fracture takes place. That means, okay, so the material is absorb energy so before fracture. Okay, so that is the definition of toughness. Okay, the toughness is measured by, how to measure a toughness? Okay, the toughness is measured by a quantity okay, so is called modulus of toughness. Okay, so the toughness is measured by a quantity is called modulus of toughness. Okay, so what is the meaning of modulus of toughness? The modulus of toughness is, okay, total area under the stress strain curve. Total area under the stress strain curve. Already you know the stress and strain curve. Okay, so this is the completely stress and strain curve. Okay, so the total area under the stress and strain curve. Okay, from here to, okay, so here, okay, so this complete area, okay, this complete area under the stress strain curve is known curve, okay, so that is known as modulus of toughness. Okay, the toughness is measured by so Charpy and Isoid test. Okay, so already you know the Charpy and Isoid test. What is the use of Charpy and what is the use of Isoid test? Okay, then finally next point, toughness decreases. Then toughness decreases, okay, as the temperature increases. The temperature increases. This one also very important for competitive examinations. Okay, so these are all information about the toughness. So toughness means the ability of material to absorb energy before fracture. Okay, so this toughness is measured by a quantity is called modulus of toughness. So modulus of toughness means the area, total area under the stress strain curve. Okay, so that is known as modulus of toughness. Okay, then so in case of the toughness is decreases as the temperature is increases. Okay, so the next property is ductility. Okay, so the next property of material is ductility. Okay, so next property is ductility. Then next, so what is the meaning of ductility? Okay, so ductility is the property of material, okay, so it can be drawn into wires under the tensile load, so this is the property, okay, of ductility. Then so in case of ductility, okay, in case of ductility, the metal having more than 5%, elongation, okay, elongation at fracture is said to ductile. So this one also very important. In case of the 5% of elongation fracture is said to ductile. Okay, the ductility is measured in percentage of elongation. The ductility is measured percentage of elongation and percentage of reduction in area. Okay, so the ductility is measured in terms of percentage of elongation and percentage of reduction in area. Okay, then the ductility of metal decreases as the temperature increases. Okay, so because of the metals weak at increases in temperature. Okay, so in case of the temperature is increases, the metals very weak position will go under to, so very weak position. Okay, so the ductility is the low degree of elasticity. Okay, low degree of elasticity and high degree of plasticity and strength. Okay, so then so next one is The next one is the next property, brittleness. Okay, so what is the definition of brittleness? It is the property of material, the breaking of material with little permanent distortion. Okay, so that property is known as brittleness. Okay, so example of brittleness is cast iron. Okay, so this is the definition. The next one is, so the brittleness is dependent on temperature. Okay, so this property is dependent on temperature. Okay, so the brittle materials fails by sudden fracture. Okay, so in case of ductile materials having some stages, okay, so proportional limit, then elastic limit, plastic limit, upper yield limit, lower yield limit, then reaches to the ultimate strength, ultimate point, then finally so breaks the material. But for brittle materials, okay, fails by sudden fracture. Okay, so the brittle materials have low percentage of elongation. Okay, so that means less than the 5% of elongation. Okay, so this one also very important for competitive examination. Okay, so the next property is hardness. Okay, so hardness means to resist the material to penetration, so indentation, then scratching, etc. Okay, so this is the property of hardness. Okay, this hardness so determined or measured, okay, so by using 4 methods. Okay, so what is the first method? Brinell hardness test, then Rockwell hardness test, then Vickers hardness test, then Shore scleroscope. Okay, so tester. So these are all 4 methods. Okay, so used for so find out the or measuring the hardness. Okay, so for steels the ultimate strength is equal to the 3.45 so times of the Brinell hardness number. Okay, so this point also very important. Okay, then actually, so what is the formula of Brinell hardness number? So BHN. So this is the short form of Brinell hardness number. So BHN equal to P by pi d by 2 into d minus under root of d square minus small d square. Then capital D means a diameter of steel ball, small d means dia of indent, so P equal to standard load. Okay, so that means the force applied on material. Okay, so these are all information about the brittleness. The next one is hardness. Okay, so the next property is strength. Okay, so strength means the ability of material to resist breaking or yielding under the action of external loading. Okay, so this is the definition of strength. Okay, just what is the meaning of strength? To resist the breaking or yielding. So breaking means already you know the breaking. Okay, so yielding means change in dimension. Okay, to resist the change in dimension. Okay, so the strength is expressed as then tensile, then compressive and shear. Okay, so this is the information about the strength. Then creep. Next property is creep. What is the meaning of creep? Slow and progressive deformation of a material with time at constant stress. Okay, so what is the meaning of creep? Slow and progressive deformation, okay, at constant stress. Okay, so that is the definition of creep. So this creep is depending upon temperature and stress. Okay, so this point also very important for competitive examination. Okay, so percentage of elongation and percentage of reduction area formulas. Then percentage of elongation equal to LF minus L0 by L0 into 100. So LF means after fracture length, so L0 means original length. The next A0 means original area, AF means after fracture area. Okay, so these two formulas are very important. Okay, so percentage of elongation, then percentage of reduction in area. But what is the use of these two parameters? Okay, then percentage of elongation and percentage of reduction area are the two parameters to measure the ductility of the metal. Okay, so in case of more than 5% of elongation, okay, a fracture is said to be ductile. In case of less than the 5% percentage of elongation, okay, so that is brittle materials. Okay, so these are the complete information about the properties. Okay, so in next video, so we will see, okay, so MCQ, multiple choice questions on stress and strain curve and their properties.